Hello friends, in today's podcast we are going to discuss about hydrogen. As we all know, hydrogen is the first element in the periodic table and is the lightest element. It exists as a diatomic molecule H2 and is called dihydrogen. It has one proton and one electron and it has electronic configuration 1s to 1. This electronic configuration is responsible for dual nature of hydrogen, that is, hydrogen shows resemblance with alkali metals as well as with halogens. Resemblance of hydrogen with alkali metals. Like alkali metals, hydrogen exhibits electropositive character, that is, it has tendency to lose electron. The normal valency of hydrogen is 1. Hydrogen forms halides, oxides and sulfides. Hydrogen acts as strong reducing agent. Now we discuss resemblance of hydrogen with halogens. Like halogens, hydrogen exhibits electronegative character by accepting one electron to complete its valence shell. Hydrogen shows same order of ionization energy as that of halogens. Hydrogen is a gas in molecular state similar to F2 and Cl2. Hydrogen shows -1 oxidation state in its compounds with more electropositive elements. Now we discuss position of hydrogen in periodic table. As the hydrogen resembles both the alkali metals and halogens and also differ from them, and also hydrogen exhibits some unique behavior, therefore the position of hydrogen is uncertain and it is placed separately in periodic table. Isotopes of hydrogen. Hydrogen has 3 isotopes: protium 1H1, deuterium 1H2, tritium 1H3. Protium or ordinary hydrogen. It is the most abundant isotope of hydrogen, that is 99.985%. Its nucleus has one proton and one neutron. Mass number 1. Deuterium or heavy hydrogen 1H2 or D. It is less abundant and is present in heavy water D2O. Its nucleus has one proton and one neutron. Mass number 2. Tritium 1H3 or T. It is rarest isotope of hydrogen and is radioactive in nature. Its nucleus has one proton and two neutrons. Mass number 3. Okay, now we are going to learn preparation of dihydrogen H2. First we discuss laboratory methods. Action of dilute HCl or H2SO4 on granulated zinc. So zinc plus 2HCl gives ZnCl2 plus hydrogen gas. Action of dilute H2SO4 on magnesium ribbon. Mg plus H2SO4 gives MgSO4 plus H2. Action of water on sodium hydride. NaH plus H2O gives NaOH plus H2. By action of KOH of scrap aluminium or silicon, So this reaction is also known as Uyonos method. 2Al plus 2KOH plus 2H2O gives 2KLO2 plus 3H2. Commercial methods. So now we are going to discuss commercial methods. On commercial scale, hydrogen is prepared from water gas, also known as Bosch process. Water gas CO2 plus H2 is mixture of steam and gaseous mixture is passed over heated catalytic mixture of ferric oxide F2O3 and chromium oxide Cr2O3 at 773 Kelvin, that is H2 plus CO plus H2O in the presence of Fe2O3 plus Cr2O3 at 773 Kelvin gives CO2 plus 2H2O. And from steam hydrogen also prepared, and this process of preparation of hydrogen from steam on commercial scale is known as Lenz process. So when superheated steam is passed over iron fillings heated to 1023 to 1073 Kelvin, hydrogen is formed, that is 3Fe plus 4H2O gives Fe2O4 plus 4H2. Another method is hydrocarbon steam process. Hydrogen is prepared by the action of steam of hydrocarbons at 1270 Kelvin, that is CH4 plus H2O at 1270 Kelvin gives CO plus 3H2. By electrolysis of water, hydrogen can also be produced by electrolysis of water on commercial scale, that is electrolysis of acidified water using platinum electrodes gives dihydrogen. Here dihydrogen is liberated at the cathode while oxygen is liberated at anode. Chemical properties of dihydrogen. Dihydrogen reacts with halogens to give hydrogen halides, that is H2 plus X2 gives 2HX. Dihydrogen reacts with dioxygen to form water. This reaction is highly exothermic. 2H2 plus O2 on heating in the presence of catalyst gives 2H2O plus heat. With dinitrogen, dihydrogen forms ammonia. This process is also known as Haber process of manufacture of ammonia, that is 3H2 plus N2 at 673 Kelvin in presence of iron as a catalyst at 200 atm pressure gives 2NH3. Dihydrogen combines with many metals at high temperature to yield the corresponding hydrides, that is 2Na plus H2 gives 2NaH, that is sodium hydride. It acts as reducing agent and thus reduces certain oxides of metals, that is ZnO plus H2 gives Zn plus 2H2O. Fe2O4 plus 4H2 gives 3Fe plus 4H2O. Dear friends, you can also visit our website www.chemistrynotesinfo.com to download notes of hydrogen chapter in PDF form, or you can directly visit our Telegram channel or join our Telegram channel to download all notes of 9th, 10th, 11th, 12th, BSc, MSc or many other subjects from our channel. Okay, now we continue our lesson. Hydrogen of vegetable oils using nickel as catalyst gives edible fats. Margarine and vanaspati ghee is one of the example of this reaction. So vegetable oil plus H2 in presence of finely divided nickel at 450 Kelvin temperature and 810 atm pressure gives solid fat. Okay, now we are going to discuss uses of dihydrogen. Dihydrogen is used in the preparation of ammonia by Haber's process. It is used in the hydrogenation of vegetable oils. It is used for the manufacture of metal hydrides. It is used as rocket fuel in space research. Dihydrogen is used in fuel cells for generating electricity or generating electrical energy. It is used in atomic hydrogen torch or oxyhydrogen torches for cutting and welding. Hydrates. The binary compound of hydrogen with other elements are called hydrides. These hydrides have the formula EHX or EMHN, where E is element. These are classified into three types. First, ionic or saline hydrides. Second, covalent or molecular hydrides. Third, metallic or non-stoichiometric or interstitial hydrides. So first is ionic or saline hydrides. These are formed by the combination of hydrogen with metals which have low electronegativity values and are electropositive with respect to hydrogen. These includes elements of S block element. Ionic hydrides are prepared by the direct combination of metals. Example: LiH, KH, CaH2, MgH2, etc. Covalent or molecular hydrides. These hydrides are formed by the combination of elements of comparatively higher electronegativity as p block elements. The bonds formed are mostly covalent in character. Covalent hydrides are generally volatile. Example: H2O, CH4, NH3, HF, etc. Third, metallic or non-stoichiometric or interstitial hydrides. Metallic hydrides are formed by many D block and F block elements. Elements of group 7, 8, 9 of D block do not form hydrides, and this is referred as hydride gap. I repeat, element of group 7, 8, 9 of D block do not form hydrides, and this is referred as hydride gap. Metallic hydride are non-stoichiometric and shows electric conductance. In these hydrides, hydrogen occupies interstitial spaces in the metal lattice, producing distortion without any change in its type. Therefore, they are termed as interstitial hydrides. Example SCH2, TiH2, VH, ZrH2. Now we are going to discuss one of the best and very essential compound on the earth, which is the form of all types of lives. We cannot live without it, and that is water, H2O. Water is essential to all forms of life. It is most common, abundant, and easily obtainable of all chemical compounds. It is regarded as universal solvent. Water H2O is hydride of oxygen. In nature, water exists in three physical states, that is, water as liquid, ice as solid, and water vapor as gas. Structure of water. Water molecule is a bent molecule with bond angle of 104.5 degree and OH bond length is 95.7 picometer. You can visit our website www.chemistrynotesinfo.com to see structure of water or structure of ice. Ice is the solid form of water. It has a highly ordered three-dimensional hydrogen bonded structure. In ice, each oxygen atom is surrounded tetrahedrally by four other hydrogen atoms at a distance of 276 picometer. The strength of hydrogen bonding in ice is more than liquid water. There is empty spaces in crystal of ice. Due to hydrogen bonding, this makes density of ice lower than liquid water. Hence, ice floats on water. So I think today you get answer why ice floats on water. If you want to see structure of ice, please do visit our website www.chemistrynotesinfo.com to see its structure, and also visit our Telegram channel to download its PDF notes. Now we are going to discuss chemical properties of water. Dissociation of water. Water dissociates into its ion. H2O plus H2O gives H3O plus, that is hydronium ion, plus OH minus. Amphoteric nature. Water has the ability to act as on ions, on acids as well as bases. I repeat, water has the ability to act as acids as well as base. Such kind of behavior is known as amphoteric nature. That is, H2O plus NH3 gives OH minus plus NH4 plus. H2O plus HCl gives H3O plus plus Cl minus. Oxidizing and reducing nature. Water can act both as an oxidizing and reducing agent in its chemical reactions. With active metals, water behaves as an oxidizing agent, while with highly electronegative elements, it acts as a reducing agent. 2Na plus 2H2O gives 2NaOH plus H2. This is an example of oxidizing agent. Now we discuss example of reducing agent. So it is 2F2 plus 2H2O gives 4HF plus O2. Formation of Hydrates. Water has strong ability to form compounds with some metals, salts, known as hydrates. I repeat, water has strong ability to form compounds with some metal salts known as hydrates. These hydrates can be classified into three types. First, coordinated water. Second, interstitial water. Third, hydrogen bonded water. So example of coordinated water is CrH2O 6 3 plus 3Cl minus. Example of interstitial water is BaCl2 dot 2H2O. Example of hydrogen bonded water is CuH2O 4 2 plus SO4 2 minus dot H2O. Heavy water. Heavy water is deuterium oxide D2O. It was discovered by Urey in 1932. The reaction of D2O are slightly slower than H2O. Ordinary water contains 1 part of heavy water in 6,000 part of it. It is used as a moderator in nuclear reactors. It is used as tracer compound in determining the mechanism of many organic reactions. Hard and soft water. Natural water contains dissolved salts. Depending upon its behavior towards soap solution, water may be classified as hard water or soft water. Soft water. Water which produces leather with soap solution readily is called soft water. For example, distilled water, rainwater and demineralized water are example of soft water. Hard water. Water which does not produce leather with soap solution readily is called hard water. For example, sea water, river water, well water and tap water. Hardness of water is due to the presence of bicarbonates, chlorides, sulfates of calcium and magnesium. Isotopic varieties of water. Ordinary water contains 18 different kinds of water. Such as variety is possible due to different isotopic forms of water and oxygen. Hydrogen has 3 isotopes: protium, deuterium, tritium, and oxygen has 3 isotopes: O16, O17, O18. These isotopes of hydrogen and oxygen combine to give 18 different kinds of water, from which H2O is most abundant. Hydrogen peroxide H2O2. Hydrogen peroxide was discovered by Thénard in 1818. It is an important chemical used in pollution control treatment of domestic and industrial effluents. Preparation of H2O2. In laboratory, H2O2 is prepared by acidifying barium peroxide and removing excess water by evaporation under reduced pressure. BaO2.8H2O plus H2SO4 gives BaSO4 plus H2O2 plus 8H2O. By the action of dilute acid on sodium peroxide, that is Mark's method. Na2O2 plus H2SO4 gives NaSO4 plus H2O2. By bubbling CO2 through a paste of BaO2, BaO2 plus H2O plus CO2 gives BaCO3 plus H2O2. By the action of phosphoric acid on BaO2, 3BaO2 plus 2H3PO4 gives Ba3PO42 plus 3H2O2. Industrially, H2O2 is prepared by the auto-oxidation of 2-ethyl anthraquinol, that is 2-ethyl anthraquinol in presence of air and H2PD as catalyst gives 2-ethyl anthraquinol plus H2O2. Structure of H2O2. It is non-planar open book skew structure. The bond length and bond angle are slightly different in gas and solid phase due to hydrogen bonding. Structure of H2O2 hydrogen peroxide can be seen at our website www.chemistrynotesinfo.com. So do visit our website to see its structure in gas phase and solid phase. Now we are going to discuss chemical properties of hydrogen peroxide H2O2. Hydrogen peroxide decomposes rapidly on heating in presence of finely divided metals such as calcium, iron, copper, platinum, carbon, dust, light, etc. So H2O2 plus H2O2 gives 2H2O plus O2. Hydrogen peroxide acts as an oxidizing as well as reducing agent in both acidic and alkaline or basic medium. Some examples are given below. Oxidizing action in acidic medium. PbS plus 4H2O2 gives PbSO4 plus 4H2O. Second, reducing action in acidic medium. HOCl plus H2O2 gives H3O plus Cl minus plus O2. Oxidizing action in alkaline medium. Mn2 plus H2O2 gives 2Fe3 plus 2OH minus. Reducing action in alkaline medium. Cl2 plus H2O2 plus 2OH minus gives 2Cl minus plus 2H2O plus O2. Hydrogen peroxide acts as a bleaching agent due to the release of nascent oxygen, that is H2O2 plus H2O2 gives H2O plus O. Hydrogen peroxide undergoes addition reaction with alkenes to form glycols. Uses of H2O2, that is hydrogen peroxide. Hydrogen peroxide is widely used in environmental chemistry. Hydrogen peroxide is used as an antiseptic and is sold in the market as perhydrol. It is used in daily life as a hair bleach or as mild disinfectant. It is used as a bleaching agent and to manufacture chemicals like sodium perborate and percarbonate. Thank you to listening this podcast. This podcast is brought to you by Chemistry Notes Info, a learning platform to learn science and chemistry. Do visit our website www.chemistrynotesinfo.com to learn chemistry. And also visit our Telegram channel, join our Telegram channel, participate in our quiz competitions, download PDF notes, and enjoy learning chemistry with Chemistry Notes Info. Thank you to listening this podcast.